Yeah, my name is Roman. I'm in Java Developer Experience team at Uber. Even I know about some iOS and Android and Go, I'll focus on the Java context here. So another thing I wanted to let you know is here's my email address. It's not my work email, so you can write me anything you want. Even if it's related to the Uber, I'll contact with you other ways. If you find me on another social network, please reach out. I have a Twitter. I don't use it anymore, so if you write me a private message there and it's enabled, sure. But other than that, email is like the best option to reach me out. So what this talk is going to be about, this is not about the code. So I want it to be a little bit more interactive, so I'm going to ask you a couple questions. So does anyone know what language it is? Anyone? Yeah, it's not a language, it's bytecode. Yeah, but that's the last time you'll see anything code-related in this talk. It will be more about the story. It's not really about how you do things technically. It's more about how you use technical things to make it work. So yeah, one thing is, what was the problem? Where we start from? So let's start from some of the beginning. One of the important things is I'm a historian here. I have only joined Uber in 2017, which is slightly more than a year ago. And I'll be talking a lot where I didn't make the decisions, but I'm saying we because I'm often supporting them or often not supporting them, but taking responsibility of them. So yeah, so where everything started. Let me ask a couple of questions. So who been to the talk about our data team? Anyone? Data team? All right, so you know a little bit, but not a lot of you. So one of the big things that Uber grew really, really fast for a long time, and the original idea behind everything was let every team use whatever they want. The only thing we require from them is that it works for our product, that we can scale, that we can do all the ton of rides that we do, that we can grow year by year a lot. And it worked. You just make the decision, it works. You hire a person, they know how to use AWS. Sure, let's use AWS. You need to solve some other problems. Yeah, Hadoop, sure. How many instances of Hadoop? Let's use one for data, obviously. But also we want to have another solution of Hadoop that we want to use for experimentation. Yeah, let's do it on AWS. Oh yeah, and also let's set up a couple more clusters because teams decided to do so. Why not? So it sounds good. You as an engineer, wouldn't you want to work in a company where you join and you do whatever you want? I would think I want to, but there's a couple things. So one of the things yeah, it looks good on the paper, but you make this trade-off early on, and later it's yeah, it looked cool, but now I need to support it, and I'm on call because everything is mine. I need to be on call for my database instance because yeah, I set it up. I need to be on call for everything else. And then people use me, and I don't know, something works, something doesn't. So here's a couple of the problems. When you have a more concentrated environment, you need only a couple people in the company know how to cook Hadoop, and they do this. Now you have people who know how to cook Hadoop in very, very different ways across the company, and they are opinionated and have to do these things. Another thing is, yeah, common library, sure, but now, how many of you have ever had conflicts with Guava? Anyone? You want to depend on something, and it wants one version of Guava, and then you depend on something else, and it wants another version of Guava, and nothing works together? No one? All right, yeah, okay, some people did. Yeah, everyone else has been lucky, but that happens all the time. And now, if it happens inside your company, and you have a technology you have to depend on because you need to use it, and suddenly you cannot because it just needs a different version of Guava. Or I'm telling you Guava because Guava is so good, everyone uses it, but also not backwards compatible. So things go wrong. Another thing is every single team needs to know how to set up build system, how to set up CI, and obviously everyone will use favorite build system. So, you name a combination of language and build system, and we had it. Anything. So another problem is like dependencies. You just take a look on any Cassandra library or Guala, and you just calculate among the company like how many versions of it do you use. Probably most of them, maybe not all, maybe not the oldest ones, but probably most of them will be there. And then now with all of this, you want to change something. You discovered a problem. You are author of standard library, and you discovered a problem. And you're like, yeah, let's fix it. So, you fix that. Yeah, you release the fix. Now, when everyone will get this fix? You don't know. People don't really know that they need to update the version because they don't know that they need to. And also, other problem with this is, imagine there's something important happening. Imagine there was GDPR or something. I heard there was a big deal. And then you know that yeah, the fix is easy. You just update the thing, client library, and every user will use the thing and everything will be fine. But when? And regulators don't wait for you to do so. So you need to go over all these build systems, figure out how all these code bases work, do the thing over and over again 500 times, and it kind of gets messy. Another problem is now that you're author of a common library, you yeah, I don't know. I don't have any idea. Let me just do this change, declare it as a broken version, and yeah, I'm done. It's a breaking change. I don't know. Update it at your own risk. And that's not really a good approach inside company. Yes, it works in open source. In open source, obviously, you cannot be responsible for what everyone else does. There's no question. But inside of the company, you can afford to be more effective than that. And so that was the problem that we tried to solve. Now, as we all know, you should be trying to solve your problems. You shouldn't be trying to listen to some tech talks of someone coming from Uber and telling yeah, we did this thing and it worked for us. And you just, yeah, Uber did this thing, it worked for us. Let's just do it. So, let's talk about what did we do. Be cautious about that. I'm intentionally using the more vague term as possible because I don't want you to come back to your company and say, yeah, it worked for Uber. Yeah, let's do it. Because one of the things you need to do is contextualize. You don't know all the variables why it worked. You need to figure out it inside your company. There's a lot of things that work for different companies. And, you cannot tell that one is right or wrong because everything is. So what happened is Android team got tired of this. So they were okay, let's try something different. Let's reduce this fragmentation. Let's make it work. And what they did, they built something big and singular. Yes, there's a thing, no? Monorepo. So they decided, okay, let's go for monorepo. Now, the question is, how you build monorepo? In a lot of cases, people think yeah, just dump all the code together. It works for some big companies we heard about. Just dump it and everything will be good. But no, it's actually not. And here's few important things that they did. Monorepo is a delivery system. It's not a Go. It's a tool. The only thing that matters is how you use it. You don't have to use monorepo. You can do some other things. We just decided that it's much easier to deliver few things that we wanted with monorepo. So one of the big things we did is they built a tooling. They had a good tool set. They had a tool chain. They make sure that everyone uses tool chain, and you don't have to download it from somewhere, manage your laptop in some weird ways. No, you just check it in. You know that everything's configured. You build, it works. Another thing is that they had a platform. So not just tooling, but they introduced a team who started developing, here's the standard platform we used. Here's how you solve the problems. Here's how it works. And it helped them a lot. So yeah, and that's just a couple things. There's very little to it, except it was a lot of work. And not everyone was happy, obviously, because, there's people who don't like monorepos. There's people who used to love this freedom of doing what they want, but at the end, we need to do what works for us. And so last year, company decided, okay, you know what? Let's take a look of what worked and what didn't within the company and see what we want to do. So after company gathered, there was a big initiative to do this. They decided, yeah, we like what Android did. Let's do this for the company. And that's the lesson I want you to derive from it is don't look on what others do. Look on what works in your company. Look on what other teams within company done and what they keep doing to make it work. Now, here's a couple lessons that we learn. One of the things is people don't like friction. People I want to develop fast. I want it to be great. I just want to write code and everything should be working from the get-go. But Formula One cars, they need friction a lot. They need to stay on the track. So even there's a lot of friction. Let me get out of the way of the text. There was no useful text in the slides before nowadays. So there's few things that you already probably doing. I hope you do. So you write your tests. Oh, wait, pointer doesn't work. Yeah, so you write your tests. Maybe you don't. I don't know, but you probably do. You expect them to pass. You don't just land things when you know that your test breaks. Sometimes you don't know, but when you know, you don't. You probably use some kind of linters or static analysis. Someone heard about AirPron? AirPron, anyone? Yeah, so if you didn't, AirPron is this amazing thing Google did. It's like a linter, but it's not. It's a Java compiler plugin. So instead of usual linting, you get something much better, where if it doesn't work, your code just doesn't compile. So, you cannot just say, nah, doesn't matter. No, you have to follow it. So yeah, linters and static analysis is really good. Test coverage. Now, there's a lot of ways to approach test coverage. I'm not talking about religious test coverage where everything needs to be 100% test. I've seen too many assert true equals true methods just to make sure that there's line coverage. No, you actually verify that you cover your use cases. Code review. Who uses code review? Right. Who doesn't use code review? OK, so everyone else was just quiet. So yeah. Everyone uses code review. Why do we use code review? Because there's a lot of ways to machine check your code, but at the end, having another human being look at it helps. A lot of code is not about systems and it's not about programming. It's all about other engineers and people need at the end. So other thing is RFCs. I'm using term RFC because it's most used open source, request for comment. Probably when you're doing some big redesign, you are writing a document saying that here's what we want to do, here's why, and hey, do you know if it will work, if it wouldn't? Let us know. Documentation. You need to have documentation, some kind or another. I'm not talking about code documentation. If you write in a system other people use, and then it doesn't work, it blows up, you need to have a place to point to and say, no, I wrote there. You see? You just misuse it. No, I'm kidding. You need your users to have proper documentation. Now, another term I want to introduce you now is a technical tax. So we're talking about friction. And most of the time, I were talking about where you intentionally slow yourself down to benefit. Now, other thing I want to tell is sometimes you are being slowed down by tools and methods that other team introduce to make sure you're safe and to make sure that others within the company is safe. So, if you write in a library, you kind of want it to keep working. You kind of want to make sure that when you do a change, work doesn't blow up, and you don't just say, oh yeah, I made this change, it's a breaking change, it's everyone else's problem to migrate. No, that's one of the things why we want to use monorepo, because it guarantees us propagation of change, and you cannot realistically submit a change that will not pass test of some of your users. Now, other thing is technologies. If you use the same technologies that others use, maybe it's not optimal for use, but you know that there's other people in the company maintaining that you'll be able to learn from experts, that you'll get support. that you'll be able to understand that when you move from team to the team, you're not moving to another company altogether, that they will use approximately the same set of technologies and you can stay there. And yeah, just be closer to users. Like at the end, most of the people who work on the framework, we're talking about ourselves as infrastructure engineers. It's not. We are product engineers. It's just our product is used by other engineers within the company. Our users know where we sit, can come to our desks and tell us we're wrong. And that's a curse and a blessing at the same time. So one important thing, have a team. Like always have a team. When you have some problem, first of all you need to do is you need to have a team that is responsible and that has agency to do changes that they seem necessary. Because if you just have a team who they're responsible for these changes and they come okay, we need to change how we process data because right now we're spending too much money and it doesn't work. And they've been told, no. You are responsible, but you will not do this change. No, they need to be this. And one other thing is why the team is so important. Because if you work on some kind of team company that sells product to external engineers, you probably have product managers, you have developer advocates, you have other people who sell your work. Within the company, no, you're infrastructure team, so you need to do all this work yourself. You are the product manager, you are developer advocate, you are all of these roles, and you need to understand that it's much more beyond just writing your code. You need to be responsible for the solution of the problems your users have. Now, pick the right build system. People underestimate how it is important to have the right build system. So let's do a little questionnaire again. So who uses Maven? Who loves Maven? Okay, there are some people who love Maven. That's great. Who uses Gradle? Who loves Gradle? Okay. Who uses things like Scala build tool or other esoteric systems that just language specific? Do you love them? Cool. So all the technologies. Now let's get two things on this slide. So let's start from Bazel, surprisingly. The reason why I'm starting from Bazel is I want to ask a question. Who been to the Dave's talk yesterday? Someone? Okay. If you haven't been to Dave's talk, go watch it. Don't watch recording from this conference. There were some technical difficulties. You'll see this if you watch recording, but Dave probably had more technical talks before on the same topic. So just find one. Dave will give you a good breakdown of why Bazel is good. It is good. So in my mind, Bazel is the best system I ever had, build tool I ever had chance to work with. At the same time, I'm going to tell you in a couple of minutes why we didn't use Bazel. And that's pretty interesting. So let's get back to Gradle. So what is Gradle in my mind? In my mind, Gradle is Maven done right. Also with Groovy DSL and things. So it's pretty good. It's easy to start. Developers know it. Developers love it. There's a lot of integration. It's easy to extend. You just drop in the plugin and it works. Now, what's the problems it brings? So the main problem I find with Gradle is it's too easy to extend, and it's not restrictive enough. And as I talked about freedom earlier, the less restrictive you are, the more random things you can do. The more random things you can do, the less framework owners can optimize for you. Once you restrict developers to some simple box that says the only extension point you have is you implement this box that has declared inputs and declare outputs, and you have no side effects. And you can do anything you want in this box as long as it is box. Once you do this, surprisingly, a lot of optimization can happen within your build system. Your build system just does what they can to optimize it. They can do caching, they can do distributed build, they can do whatever random things they can to make it work for you. And you don't need to put in effort. Now, that's Bazel for you. And that's Bug for you. So what's the difference between Bazel and Bug? Realistically, for end user, for developers, they're not so much different. They both use Starlog syntax. It's very similar. They have slightly different rules. Documentation explains what the difference. Now, the big difference is when you start considering how it scales for you. Now, Bazel is developed by Google and Bug developed by Facebook. And both of the systems developed by companies for themselves, for their needs. So when you pick the tool, it's a good idea to figure out what is working closer to your needs. And what we found that while Bazel is great and it is very consistent, this consistency sometimes backfires. Because the moment you cannot fully control the developer laptops, and the moment when you can have slightly different versions of Java, like minor version, Bazel starts saying, no, this Java is different. The rule keys are different, so I will not use the cache, I'll rebuild. And in ideal world, you just don't have this problem. Now, in our case, we just been in a situation where we knew that we don't have control over it, where we still want developers to be able to set up their laptops in their own way. Another thing is we do build on laptops. And we do build on laptops from crappy Wi-Fi. We work from home. We do all things. So Bug showed that it excels at optimizing resources of the current machine to the maximum with some sacrifice of consistency. They cache Java compiler in memory. They do a lot of other fancy stuff. They calculate ABI based on the sources rather than class files, so they can start compiling the libraries that depend on your library before the library ended compiling, and all other things. And the most important, I talked before, we started from Android. And there's an interesting thing. For some reason, it seems that Facebook had much more need in having built systems that can build humongous Android app that Google did. So the Bug seemed to support Android much better at the moment. Now, what I know is Bazel is actively developed, and they are either catching up, or they already caught up, and they're as good in supporting Android. But we already went with Bug. Other thing is we found we were able to contribute to Bug a lot. And here we go to the next thing. We did something interesting. We decided that we want to keep both benefits of Gradle and Bug. And what we did is we did an OKBug, which is the system that uses Bug as backend, but keeps Gradle as configuration. So if used correctly, if used in monorepo, where we have control over Gradle configuration, it has benefits of Gradle and Bug. If used incorrectly, which we also did, obviously, it has downsides of both systems. So, and surprisingly, a lot of people use OKBug. A lot of the companies use it and find it to be the entry drug into world of build systems like Bug and Bazel. We are talking about Bazel, we are considering to see how much work it is to make OKBug also wrap Bazel the same way as it wraps Bug, now that both of them are using Starlark. And then people will be able to choose what they want more, correctness or speed, and how much they want it, and they'll be able to transition from one to another painlessly. Now, other thing is, I assume you're already using Gradle. Let's assume it. Because if you're using Maven, there is a lot of migration tool to Gradle. And if you're already using Gradle, now it's much easier for you to start setting up OKBug. And at the first stage, everything that you had in plugins that are not compile time will stay in Gradle. You'll keep doing this over and over again. And the compilation itself will be in Bug. But as you go, you can move code over, and you can slowly move functionality to the Bug. And eventually, you'll be able to have only pure Bug with Gradle resolving only your dependencies. We are working on making OKBug even more powerful, and we're working on making it a standalone tool just to resolve dependencies and output your build target set that has all the dependencies resolved for you. And then once we have this, you'll be able to build even faster without invoking Gradle, while having to run Gradle from time to time when you want to update dependency set. And it worked great for us. So now we talked about monorepo, and one of the problems with monorepo is Git doesn't scale, or does it? So let's set aside what I've been told that in 2019, someone who I kind of trust told me that someone who they trust told that Git will be sold by 2019, so probably it will be. But even if not, if you're in the state where Git does not scale for you, you're probably in a good place already, or you're doing wrong things. So, don't put garbage into Git. Here's a couple of things about Git that you need to know. It's distributed build system. It's not a centralized build system. So when you clone the Git repository, you get entire repository. You get every single revision, every single version of the file, everything. And it's quanted as files. So every time you update the file, you get another snapshot. And if this file is 50 megabytes jar file or some images and something else, yeah, you have every single revision, and then you get is gigabytes, and then it's slow, and then it explodes. Now, we know developers love Git. Like, everyone loves Git. There's no denying this. Yes, you can say, like, no, let's use something else. Git is bad. Git doesn't work. No, people just love it. Like, people don't want to get away from all the power of Git. Even this power is super useful to shoot themselves in the feet. So how do we work around that? So, there's a couple things you can do. So auto-generated code. Whoever submitted auto-generated code to their Git repository? OK, there's a couple of people. So why did you do this? Like, your build tool can, oh, wait. You're probably not using build tools that caches. So going back to a couple slides back, use the right build tool. Use the build tool that caches. Gradle can cache. Like, Gradle does not have as much correctness as Bazel or Bug, but there's a lot of plugins that cache results, and they don't rebuild what's already built. So just let your build tool generate a code. Third-party source code. We're talking about Java. Like, don't build from sources, use jars. If you have to build from sources, do a proper fork, create a proper repository, do the changes that you deem necessary. Do not just copy over code, because it will be so easy for you to do some innocent change. Oh, yeah, let's just, like, I'm refactoring entire code base, and I'm replacing this method with this method. And then you want to update to later version, and I'm like, oh, wait, how do I do this? Like, I cannot merge. Do a proper fork. It will be much easier to rebase. Don't have pre-built binaries. Don't put large testing data. Basically, don't put anything that's about 2 megabytes, and 2 megabytes is a stretch. Ideally, you only have your source code and, like, some testing data. Now, where do I put these things? That's like, so, like, put them in the right spot. So auto-generated code, like, during build time, use your build tool. You have your build tool. If you don't have the good build tool, get the good build tool. Things like copied source code, pre-built binaries, anything that's, like, not a source code, like, put it in some kind of binary storage. Like, you can have key value binary storage. You don't need to make it complex. Things like, I don't know about Bazel support here. That's the thing I don't know. Bug has some interesting feature where you can download files in your build time, but you specify the hash of this file. So even if it's somewhere else, from the build tool perspective that it's reproducible. Because if it tries to download and it's something else, it would just say, nah, it changed. No, I don't want it to change. So you can do this. And it's really easy. Like, there are a lot of solutions. There are commercial solutions. There are free solutions. Just pick whatever you work. Like, you can implement one if you really want. Just don't put it into Git if you want to use Git. Now, control your submit process. One of the things that we did is with CI/CD, we had some ability to do a lot of control. So the goal here is you should never, ever have the red master. It shouldn't be there. There's FICA tests, which is a problem. So they need to be dealt with separately. But the thing that we implemented is submit queue. So what it does is you can never push to master. It's at the end, we're not using Git as distributed version control system as it was designed to. No one uses it like that. It's a centralized system. So what we do is when you want to land something, you just do land, and you wait. And when you land it, it goes into the queue. And then we have a system that just takes the first item from the queue, looks at it, tries to apply on the master, runs all the tests on the master that have changed. Going back to Dave's talk about Bazel, sorry, not Bug. Bug works the same way. That's why I'm like, you can use them. Like, you can replace one term in another from perspective of end user, and it wouldn't change much. So what's the Dave's, like, seriously, like, what's the Dave's talk? And because you only have to build what changed, it's not so much, and you can ensure that you run every single test on every single commit. Now, obviously, if you do it serially, it wouldn't work. So as we grew, as we onboarded more and more, the build system, the CI build system became more and more complex. It started speculating. It started arranging commits in the groups. There's a lot of speculation you can do. There's a lot of machine learning you can do. It's a very fun problem. But at the end, the same goal applies. Everything that goes to the master needs to be green before it goes to the master, not after. We still have master build because nothing is perfect. It's possible for these things to sneak by. It's possible for things to break where they shouldn't. But that's one of the savers that ensures that people do not do breaking changes. And maybe in your company, you can do a code review that will catch most of the things. Maybe you can have a diligence to run tests. Maybe there's other things. But at the end, it's really easy to have a merge conflict that is not merge conflict. You understand what I mean? So you did something, and it works, and all the tests are green, and you tested it, you got it reviewed, everything's great. And then someone else did the same thing. And you're in a big company, so that happens quite often. And then both of you just say, yeah, I'm ready to push. And both of you pushed, and you had no merge conflicts because you updated the same logic in two different places. You know, you fixed off by one error. And coworker of you fixed off by one error 2 lines later. It's auto-merge, everything's fine. And then it goes to master. And then your app breaks because, you also didn't have it. OK, if you didn't have test for that, it wouldn't fix either, but, You got a red build, you had to revert it, go back, fix it, things like that. So other thing is ownership. So you need to make sure that for every single thing, you have a team. One of the failure scenarios that I've noticed is when people are being assigned temporary, and you just get people like, oh yeah, let's grab this person from this team, this person from this team. You now a target group that is responsible for figuring out this solution, and then after that, get back to your teams. So you get the systems that some people wrote down really, really fast because it solved the problem and then went off. And then something changed, and that system is still there. And when you're like, can you fix this? And there's no one to ask. So when you do anything like this, you need to have a team, and you need to make sure that you always have a team. You cannot rely on people. And what I mean is if you say, here is a Joe responsible for that, the Joe may change a job. The Joe may want to work on something else. No, you need to have a team. And the team, the same Joe will be in this team, but you know that when Joe leaves, the team is still there, and you'll hire someone else. And the team is still responsible. And, more like this kind of ownership. You need to make sure that that people really understand that their clients are their coworkers, and they treat all their work as a product that their coworkers can use. And if they build a data solution, if they build tools, if they build something else, they are responsible for it to keep working. It needs to run. And so, right now, there's a couple of things that I want you to remember from this. The most important one is you need to have the team. I don't know, have I repeated it 50 times already? No? Let me just do it real fast. You need to have a team. You really need to have a team. You need to have it. It's essential. It's one of the bigger things is if you are part-time build tools expert and part-time Java compiler expert, and also you tune performance, and also you write other things, and also you want to learn Go, but you're still using Java. No. For everything, when it scales, you need to have a team that's responsible for the specific things. The individual engineers, maybe better. Individual engineers may know about a lot of things and do a lot of things, but the team needs to be responsible for that and have an agency to change things. You need to learn from others. Most of the people who here want to learn from others. Someone just tired and want to have a rest, that's fine. You want to learn from others. You want to understand how other people do their things. And yeah, that's good. But never, ever go with, I know it worked for the company X, so it will work for us. It wouldn't. The good idea is, I know it worked for the company X, so it may work for us. So let's take a look if it will work for us. But maybe it wouldn't, and we need to pick something else. Pick good foundation. Your build tools, your CI, your approaches. If you pick them right, if you pick them at a time, you'll be able to adapt to the thing that changes. If you just hard code your initial requirements and keep it right there, yeah, it will run for some time, but wouldn't last for long. Pick the right tools. There's a lot of things available already. You don't have to implement things from scratch. Pick them, figure out what tools are there. A lot of the infrastructure tools are being shared by companies. Luckily, for some reason, companies no longer saying that their tools is competitive advantage, so they need to keep it to themselves. They are ready to share your build tools. They're ready to share CI environment. Sometimes they even make it into business and sell support for that, but that's only better because you don't have to also have a team that supports that and have a team that develops that. But also, do adapt them. Like, if you have the tool and you see it doesn't work for you, like, you can fork it and adapt for you. You can pick the other tools that works better for you. You can contribute back because it's open source and make sure that your fix works for everyone. But, doesn't always work still. Do not conflate goals with methods and problems with solutions. That's really important thing is, when I'm talking, we used monorepo, and we did so much work to have a monorepo. Some people will say, yeah, so monorepo solves the problem. No. Once again, it's a delivery system. It's not something that you need to have your solutions. It's just something that you use to solve your problem. And same, sometimes people come to me, like within the company, and ask, because I'm working for DevTools, and a lot of the times I'm providing the support for things that don't work. And they say, like, hey, how do we migrate this plugin from Maven to Gradle? And I'm like, OK, so what's the problem you're trying to solve with this? Let's not talk about how we migrate the solution, and let's go back and figure out what was the problem and try to figure out what kind of solution we can find for this problem with Gradle. And sometimes it is migrating the plugin. Sometimes that's already good. But often it's, no, they use only like small subset of the functionality, and the only real thing they want is they want their problem solved. Yeah. And 51st time, have the team, have the team. Yeah. And, I kind of ran through it a little bit too fast, so we have a lot of time for questions. I hope you will ask questions. I seriously want you to disagree with me if you can. Yeah, the microphone is coming.
Yes.
I can, but I want everyone else to also hear you.
One, two, one, two. OK, so I kind of have 3 questions.
All right.
First, did you mean that, let's say, we have 10 teams, and we will introduce team number 11 that will control every team, what Java version they use, which Maven, Gradle, or whatever other tools they use, Jacoco and stuff? Do you mean that?
I mean, in some way, yes.
Do you have such team in your company?
Yes, we do.
Actually, we have the similar team, and it's a bottleneck for delivery. Do you control that team so they don't stop you? Like, sometimes they say, you cannot use that tool, but we will not give you alternatives. Do you have such issues? And if yes or no, how did you solve them?
So the thing is, as I said, we are actively changing this. So even if we have this team, it's often not the bottleneck, and often when it is a bottleneck, do you remember my slide with developer tags? So often it prevents people from shooting themselves in the foot in the long run. It prevents people from introducing the solutions that are needed right now, but will not be useful in the long run. So yes, it is a friction, but it is sometimes necessary friction. When it isn't, we try to change it.
OK, thank you.
Was it 3 questions? OK. Anyone else, please? Questions?
Hello. Thank you for the talk. How do you define a team? So I guess that could actually just be a couple of developers being in a team, or do they also need a manager? And who would then decide when one leaves and stuff? How do you fill up the team again?
So that's like a very, I think in my mind, I define a team where there is something that's called a team within company. It can be a couple of people, it can be one person, as long as their promise that this team will remain. Their promise that, like, if the manager leaves, the director will hire another manager. If people within team leave, there will be rehire for the people. The team will expand as necessary. Sometimes you'll make a decision that you no longer need the team, but then you'll know that all the things that the team is responsible for need to find other owners. The thing is, like, when you have just people who have an initiative and just do the thing because they have an initiative, it's very hard to have a formal responsibility for the consequences.
Right. Thank you.
Hi. As I heard, in big companies, it was some practice related to writing own tools for growing up the developers and for reaching new titles. Did you have such practice in your company, or maybe heard something related to big companies like Google, Amazon, Facebook, related to this?
I may have heard about the things like odd rules. A lot of these rules are created to make people happy, and they're still unhappy about that. Like, once again, like, this is not a topic I'm very proficient with. I'm not a manager, I'm an engineer. And a lot of these rules, I think, are created to make sure that within your big company, in different teams, you are not being promoted at a different rate. So there's no case where you need to go to this specific team, because if you are in this specific team, you'll get promoted for no reason at all. And if you're in this other team, then, like, no, good luck with that. So yeah, I think these rules are necessary. Like, nothing is ideal. As with programming solutions, you need to fix them. Stay flexible. React to feedback. Like, at the end, like, it's these bigger systems do not behave much different from the code.
Hi, thanks for the presentation. Actually, my question about GitLab.
Can you be a little bit louder?
Sorry. Is it better? Yeah.
Yes.
Actually, can you compare with Bug with GitHub? Actually, my team uses GitLab, but GitHub is more popular. And can you also, second part, can you say something about cloud deployment, for example?
Wait, you want me to compare what with GitHub?
Deployment pipeline, for example, how you deploy, building everything, deploying. Do you have something like this in Bug, or?
I mean, like, Bug is the build system.
Yeah, and then afterwards this build, what happens with the build?
You use it in the way that you want. Like, we are using Jenkins still. Like, we had to cook it a lot. We are considering ways to get rid of Jenkins. We haven't got out of there yet. We build things in, like, we have a custom workflows. We are not using anything default. We need to figure out what we need to do. With Android, we build apps, we run necessary UI tests. With backends, there are a lot more different microservices. So every microservice may have their own workflows. We have some standard workflows too. I haven't used GitLab myself. And with cloud solutions, I know there's some, like, for example, I know about Bazel cloud build, but I don't know how much of the CI they have. So at the end, like, in the big company, the thing is you have enough need to customize, and it starts becoming reasonable to put effort into it. Because you can bring a solution that works much, much better for you than you just take something ready. The smaller you are, the better is to take something ready and not to spend 5 engineers, which may be 20% of the company, to build a CI for you.
Thanks.
All right, anyone else wants to ask something? Right, oh, one more here, behind the column. Can you bring the microphone here, please?
Hi. What do you think about rotating teams on production support? Because we had a project where management insisted, so like every 2 weeks, a different team responds to different production failures. So basically everyone knows how to fix everything, not just one team responsible for some one feature.
So when you say rotate in different teams, it's pretty nice that everyone can get expertise, but sometimes imagine like you need to rotate in so many rotations that you don't know, like you have to know everything, but you don't know anything. So it makes sense within a certain organization to have a common on-call rotations. It may be rotating the team, it may be rotating engineers. One thing we noticed, if you include in your on-call rotation a lot more people, you tend to write better documentation for on-call processes because you know that all the small hacks that you put in place, not everyone may know about them. And when you yourself have to fix some production problems, you really appreciate others people writing documentation how to debug them. So yeah, I think it works well as long as the scope is limited. As long as if you work on data team, you can support different data projects. But if you are Java engineer, you don't want to be in rotation of supporting C++ code, because you just don't know. And yes, you can be in rotation and you can work on delegating and calling to the right person, but at the end it's much better to just have the correct on-call schedule. All right, one more question from here. You're really making me happy with this amount of questions.
So do you have a technology menu and a list of who to contact in these different technologies? So do you have a web page or somewhere where normal developers can look up who to call?
We have some documentation. Once again, a lot of things are constantly in flux and a lot of documentation is not up to date, but you can get to the right people. We have like chat channels and like overall we have some, but it doesn't always work. Like that's, I'm sorry for the weird answer, but I think like that's how most of the things in the industry work.
Yeah. So I'm from a big company, and we have everything, I think. And it's really, really difficult for a new guy coming into the company to know where to get support and da-da-da. So I can highly recommend to write down every technology you have and just list a team name or mailbox or whatever chat channel. Or
yeah, we have something like that. The problem is it's not always up to date, and in the past we not always, as I said, like there was a fragmentation, everyone did what they wanted. So we not always followed the idea of people who are responsible for the thing staying there. So you can have documentation, yeah, this team is responsible for that, and the team no longer exists. So, you know, having this
sounds like you need someone with responsibility to keep it up to date.
Yeah, you know, just go meta. Have another team that's responsible for assigning responsibilities. But we want to still stay flexible and stay fast. We don't want to hang in the bureaucracy. You know.
Right. Thank you.
Right. I think people want to have some rest because it was a long day and there was a lot of technical talk. So if someone wants to chat with me, I will be available here. Otherwise, thank you so much for your attention.